I want to welcome you to the video lecture for section 3.3. This is for MGF 1106, and my name is Jorge Gabriel. So, the previous lecture we spoke about the conjunction and disjunction, constructing truth tables for those two connectives. And in this lecture, we're going to talk about the conditional and the biconditional. So we're going to construct truth tables for conditional statements. We're going to identify logically equivalent forms of a conditional. We're going to go ahead and do alternative wording to write conditionals, and then construct truth tables for biconditional statements. So, conditional statement. In order to understand when a conditional statement is true or false, let's consider this example. Mr. Gates, the owner of a small factory, has a rush order that must be filled by next Monday, and he approaches you with this generous offer. If you work for me on Saturday, then I'll give you a $100 bonus. If we let W represent you work for me on Saturday, and then B will be I'll give you a $100 bonus, then this statement has the form of if W, then B. So we must examine 4 cases to determine exactly when Mr. Gates is telling the truth and when he is not. So the first case, W is true and B is true. So you come to work and you receive the bonus. In this case, Mr. Gates certainly made a truthful statement. Case 2, W is true and B is false. You come to work and you don't receive the bonus. So Mr. Gates has gone back on his promise, so he's made a false statement. Case 3, W is false and B is true. So you don't come to work, but Mr. Gates gives you the bonus anyway. Oops, sorry about that. So then let's just think carefully about this case because it differs from the way we tend to use if and then in everyday language. So when you listen to Mr. Gates, do not read more into his statement than he actually said. You do not expect to get the bonus if you do not come to work because that is your experience in everyday life. However, Mr. Gates never said that. You're assuming this condition. So remember that in logic, a statement is either true or false. Therefore, because Mr. Gates did not say something false, he has in fact told the truth. Case 4 is W is false and B is false. So you don't come to work and you don't receive the bonus. So in this case, Mr. Gates is telling the truth for exactly the same reason as in case 3. Because you did not come to work, Mr. Gates can give you the bonus or not give you the bonus. In either case, he has told you a falsehood and therefore he is telling the truth. So here's the truth table for a conditional statement. And as you can see, the only time a conditional statement is false is if you have a true followed by a false. Now, for a conditional statement, if P then Q statement, P is called the hypothesis and Q is called the conclusion. Now, a conditional is false only when the hypothesis is true and the conclusion is false. So here's an example. We're going to construct a truth table for the statement. Again, by now you know that I don't like exactly the way the book does it, but we'll just follow along for this example. Now, because there are 2 variables, P and Q, the truth table has 4 rows or 4 lines. As usual, we first consider the order of operations as we indicated above the table. And then so you can see that they start with P and Q and then not P. And then they do not P or Q. And then, so we're going to use this column here in step 1 and step 2 to go ahead and calculate step 3. And then they do not Q, and then of course they do not P and not Q, and then they go ahead and they finish it off. So as you can see, step 1 is connected to step 2, the statement in step 2, and that's the if and then. So a true and a false is false, a false and a false is true, a true and a false is false, and a true and a true is true. Now, some different forms of the conditional. The converse, the inverse, and the contrapositive are 3 statements that derive from the conditional. So we can derive the following statements from the conditional if P then Q. Then the converse has the form of if Q then P. The inverse has the form of if not P then not Q. And the contrapositive has the form of if not Q then not P. So the following table will help you to remember how to construct these derived forms of the conditional. Again, the conditional, if P then Q. In the converse, we're going to switch P and Q. In the inverse, we're going to negate P and Q, but we don't switch the order. In the contrapositive, we negate both P and Q, and we also switch the order. Now, we're going to rewrite the converse, inverse, and contrapositive statements in words. Write in words the converse, inverse, and the contrapositive of the statement. If marijuana is legalized, then drug abuse will increase. So to understand this problem better, we first write the statement symbolically as if M then D, where M stands for marijuana is legalized and D stands for drug abuse will increase. So we next write each of the derived forms symbolically. Now to form the converse, we switch D and M to get the form if D then M. So translating this into words will give us if drug abuse will increase, then marijuana is legalized. Now the inverse, we negate both M and D to get the form not M, if not M, then not D. And then we're going to write that as if marijuana is not legalized, then drug abuse will not increase. Now to form the contrapositive, we negate both M and D. We'll also switch them, so we're going to get if not D, then not M. So we're going to write this as if drug abuse will not increase, then marijuana is not legalized. So which of the statements are logically equivalent? So we have the conditional, we have the converse, we have the inverse, and the contrapositive. So we will answer this question by comparing truth tables for all of these statements. And so you can see here that we have P and Q. So we have the conditional, we have the converse, we have the inverse, and the contrapositive. So the conditional is logically equivalent to the contrapositive, and the converse is logically equivalent to the inverse. So some alternative wording of the conditionals. Q if P. Here, the if is still associated with P, even though it occurs later in the sentence. P only if Q. Recognize that only if does not say the same thing as if. The if condition is the hypothesis, and the only if condition is the conclusion. P is sufficient for Q. This is the sufficient condition is the hypothesis, and Q is necessary for P. The necessary condition is the conclusion. So we're going to rewrite statements in if and then form. So write each statement in if and then form. Your driver's license will be suspended if you're convicted of driving under the influence of alcohol. You will graduate only if you have a 2.5 grade point average. To hold your reservation, it is sufficient to give us your credit card number. And to qualify for a discount on your airline tickets, it is necessary to pay for them 2 weeks in advance. So the first one, your driver's license will be suspended if you're convicted of driving under the influence of alcohol, because the if goes with the clause you are convicted of driving. That clause is the hypothesis. So we can rewrite the sentence as if you're convicted of driving under the influence of alcohol, then your driver's license will be suspended. Now, this one, you will graduate only if you have a 2.5 grade point average. The only if goes with the clause you have a 2.5 grade point average. Therefore, this is the conclusion. So we're going to rewrite the sentence as if you graduate, then you have a 2.5 grade point average. Now, the next one, to hold your reservation, it is sufficient to give us your credit card number. The phrase it is sufficient identifies the hypothesis. So we can rewrite this as if you give us your credit card number, then we will hold your reservation. And then the last one, necessary condition is the conclusion. So we write in this sentence, we get if you qualify for a discount on your airline tickets, then you pay for them 2 weeks in advance. Now, biconditional. Biconditional means that two statements say the same thing. So we're going to symbolize the biconditional as a two pointed arrow. So this is if P if and only if Q. So the biconditional is true when both P and Q have the same truth value. So you can see that if P and Q are true, the biconditional is true, and if P and Q is false, both false, the biconditional statement is true. So we're going to construct a truth table for the following statement. So you can see here that the connective is a biconditional. And then so we're going to use step 1, step 2 to go ahead and finish off step 3. And then you can see that a false is a true, a false true is false, a false is true, and a true or false is false. And that's the end of session 3.3. Thank you.